Comes on everyone, let's start off. So last thing that we did, we started with the constraints and we did method one. Method one was based on the length of the strings. Let's see method two. This is a more convenient one. We use this a lot. It also has its own limitations, but we will see that also. Others, to keep your cams on. So we have different names for this. Virtual work method. I like to call it power method. So we'll keep it simple that way. So what is the catch here? The idea is, remember we have taking ideal strings. So ideal strings do not dissipate any energy. So a string simply transfers energy from one place to another without any dissipation. Right. So that means the string itself, right, does not do any work of its own. It is simply transferring from one point to another point. Therefore, the total work done by tension is zero. Right. So that means the power due to tension is also zero. We are going little out of the chapter. So what is power? So we will talk about that first. So power is nothing but work done by time, d work by dt. What is work? Force into displacement. That will be F bar dot ds bar. That is your work done cut displacement by dt. What is ds by dt? Force into velocity, dot product. That for now, remember this thing. We will again derive this later in another chapter. So power is simply given by force dot velocity. So that means if you have a string connected to multiple blocks, right, what it does is simply it takes energy from one place, it gives to the another block. So energy is simply being redistributed everywhere. So as such, the total, there is no extra energy coming from anywhere. So the total power of the system must be zero. Others, you need to keep your cams on or else I'll start removing you from the classroom. So before jumping into that, let's talk about, first of all, let's talk about this tension. So what is this tension exactly? Again, we will discuss about this also in free body diagrams, but before that, we'll have a little discussion on this. Let's say if you have a block of mass m hanging from a ceiling with a string. So if you look at the forces acting on this block, the string is pulling up. So this force generated by the string is the tension in the string. So we call this thing tension force. That's your full name. We will simply call it tension force. So when someone catches your hand and pulls you, you feel, there is a little tightness in your hand. That's your tension basically, right? So if someone catches your hair and pulls, that's your tension in the hair. So one thing, strings always pull. That is the main important thing there. So whenever you have a string, strings always pull. Strings cannot push. Let me tell you what that means. For example, let's say we have a rope. If you have your mobile phone ka, charging cable, you can look at that. When you take your charging cable, if you're seeing into my screen, if I pull, right, it does tension. But the moment I try to push, what will happen? It will just bend, isn't it? It will not offer any resistance. So I can pull the cable, but if I try to push the cable, it simply becomes loose. It doesn't resist me. Getting it? So strings will always pull. They can't push you. So if you have a rope like this, and let's say you're holding this and you're pulling it. So if you pull the string will pull you back. So if you pull the string pulls him back. Same thing, if you try to push the string, if you try to push the string, the string will simply become, loose actually. There is no tension. So strings can never push you, they will always pull. That is how you can easily remember the direction of force for a string. Is this making sense? Strings cannot push. So we are ignoring all breaking and dollar shear having. Last class we already wrote that. Ideal condition, strings don't break. Is this part clear, everyone? So if you have a rope or something, it can pull you, but it can't push you. If you have a rod is a different story. A rod can push and pull. We will not deal with that right now. We'll see that later on. Any doubts on this page? So if you have a rope always pulls you. No. Just now we said if you have ideal ropes, right, the total power is 0. So this is the main technique that we use, the concept. So if you have a system connected by, let's say there are 100 blocks and they're all connected by strings, different strings. The total power due to tension is 0. And what is total power? Let's say if there is a first string T1 and let the velocity be V1 bar, power is F bar dot V bar, T2 bar dot V2 bar, plus so on Tn bar dot Vn bar is equal to 0. Tn is the tension on the nth block. If there are n blocks with different tensions, Vn is the velocity of the nth block. If you do the dot product of all of them and if you add all of them, it has to be 0. Simple reason, because strings, what they do, they take energy from someone and they give it to someone else. That means the total amount of, the energy still should remain constant. There, this is the main concept that we use. Let's see how to do this. I'll show you an example and then we'll do more problems on this. And the best thing about this, it doesn't matter how many strings you have and how many blocks you have. All clear with this concept? The total power has to be 0. And what is power? F bar dot V bar. Just now we derived it. It's a dot product of force and velocity. So let me show you an example. So let's say we have two blocks A and B. So step 1, label the tensions on the string. If the strings are different, they'll have different tensions. And find relation between them. Step 2, find the power on each block. Power is tension dot velocity. Step 3, add all the powers. Total power must be 0. Great. Look at this problem. We have done this. It is a pretty simple thing. Step 1, label the tensions in the string. Remember what the string does? String always pulls. See, whenever you want to draw tension, right? Imagine you are person A, right? If someone is catching your hair and pulling, how are they pulling you? Up, isn't it? The string always pulls. So this string is pulling up, tension T. Since it is the same string, the tension must be same. So this also pulls. Are you getting it? So the whole string will have same tension. So it is the same string on both the sides. So the tension will be same on both the sides. Great. Next thing, assume the velocities for anything. Let's say this is going up with VA. Let's say this is going up with VB. Doesn't matter. You assume whatever directions you want. Then step 2, find the power on. Let me add it here. Label the tensions on the string and assume velocities for the block. Now, what is power on block A? Power on block A is tension VA. Both are in the same direction. Dot product cos 0. TVA, because it's T bar dot VA bar. Power on B is T VB. That is also same. Cos 0 TVB. And this is an easy one. The total power has to be 0. We will not do like this later. I'm just showing the steps. So you'll get T into VA plus VB is equal to 0. So we got VA is equal to minus VB. Understood. That means if A is going up, B has to come down, isn't it? Clear with the steps? Let me show you one more example. Let's take a little more complex. Any doubts on this? So step 1, label the tensions and assume velocities. Step 2, find the power in each block. Step 3, add them up. Let's take something more complex. What we have done. Aditi.
So basically, because the strings transfer energy, the work done and the power.
It has to be 0. No, it is like, if there's a string between, you and me, if it is taking 20 from me and giving you 20, what's the total work done by tension? 0.
0, yeah, all right.
The sum has to be 0. There is no dissipation, there's no loss. So total has to be 0. It's simply
Okay.
taking from one guy and giving to the other guy. No one gains. The total amount of money didn't change.
Yeah.
Think of like that. Now listen to this example. This is slightly more complex, but so if you have a block here, A, let's say this is C and this is B. Now here you have to be a little careful with the tensions. So first thing, label the tensions. This string is pulling up, let it be T. It is the same string here. So this is also T. This is also T. Remember, strings always pull. This is also T. Clear with this? So technically, I can take this whole thing as one system. But if you want to see more here, if you look at B here, look at this B ka thing. So if this guy is pulling with T and this guy is pulling with T, how much this should be? 2T, isn't it? And this is connected to B here. So this also will be 2T. Are you getting the forces, everyone? Strings always pull. So between the pulley and the block, if there is a string, what does the string do? String is pulling this guy and string is also pulling this guy. String is pulling both of them towards each other. So that means here in this string, the tension is 2T. Is that direction clear, everyone? So on 2B, the tension is upward. So I'll just draw a little bigger one. So that this is 2T and this is 2T. Technically, there's no need to draw that. You can simply say this whole thing is one system and then you can say tension is 2T. Any doubts on these tensions, please ask me. This is important. So whenever you have a pulley, right, tensions will change on both the sides. If you have two strings here, it will become 2T on this side. Any doubts on this page? Then step 2, find the power on each block. So let's assume the velocities. Let's say this is going up with 2 meters per second. Let's say B is going down with 3 meters per second. And they ask you find the velocity of C. Let's say this is the question. So power on A, tension is upward, velocity is also upward, T into 2. Power on B, tension is 2T on B and it is going down -3. Power on C, I will take it as T into VC. Total power has to be 0. (2T minus 60 plus T VC is equal to 0. You will get VC is equal to -4. Means it is going +4. The signs will take care of themselves automatically. So we assume VC is going up. If I got plus, meaning my direction is right. If I got minus, meaning it is going in the opposite direction. Clear with the steps? All got this? There are two strings, na Siddesh? If there are two strings pulling one string, what will be the tension of this? It should be double, right? If two people are pulling this, so if I call this thing something like T dash, look at this thing. The pulley will be 2T, must be equal to T dash, isn't it? Clear? Two people are pulling one string. And remember, all the pulleys we are taking are massless here. So two people are pulling one. Let me take one more example. So these are all the things which we did in method 1. Remember this question, A and B? This is going with U and this is going with VB. The question was find VB. We did all the differentiation and everything. Step 1, find the tension. So T upward, T is pulling here, T is pulling here at the same string. Step 2, assume the velocities U and V are given. Total power must be 0. So A ka power will be T and U are in the opposite direction. So minus T into U. You can just write T into minus U. Power on B will be T VB cos theta. Total power is 0. You'll get T into minus U plus VB cos theta is 0. Therefore, we get VB is equal to U by cos theta. Got it so easily? There is no need to differentiate, nothing. Find the tensions, get the velocity, get the power, and finish it off. Sure with this? Let's see one more example and then we'll do more problems. Suppose if this is A, let's say if A is going up with 1 meter per second, what will be the velocity of B? Now look at here the tensions, okay? Let's start from here. Or let's start from here. If this is tension T, this is the same string, isn't it? Listen to this, everyone. Siddesh, listen to this thing. So if this is tension T, this side also will be tension T, agreed? If two strings are pulling, what will be the tension in this string? 2T. Is that making sense? Two people are pulling one string. It will be 2T.
Yes, sir.
You're getting how it is pulling there? Matlab, you have to draw like this. It is pulling T, it is pulling T, and to balance that, the upper string is pulling with 2T. Making sense? The tension is on both the sides. The tension is on the block also, tension is on the pulley also. It's like this. If this is 2T and this is 2T, then this will be 4T. If this is 4T and this is 4T, then this will be 8T. Are you getting how the tensions add up, everyone? Every time it keeps going up, the tensions will double. So there are two strings, 4T, 4T. They're pulling this one string, which should be 8T. That means this must be 8T. Please ask me if you're confused with this. This is important. You should know why the tension is doubling every time you go up. Anyone not clear with this? Please ask. Sure with this? Then you're done. So power of A will be 8T into 1. Power of B will be T into VB. I'm assuming it is going up. Total power must be 0. 8T plus TVB. is equal to 0. So we will get VB is equal to -8. Minus indicates B is going down. So if that block goes up with 1, this B will come down with 8 meters per second. Is this clear, everyone? The tension part is clear. Why the tension is simply keeping going up. If you ever been to this, science museum, right, which is there in Nerul, there is a one setup there. You have a chair kind of thing, and you have some pulleys here. You can sit there, you can pull this rope, and you can lift yourself automatically. Did you guys see that? I saw this long back. I don't know whether it is there or not. So the idea is the same thing. So this thing is actually called a force multiplier. In school, you must have studied this thing, mechanical advantage. Did you study something like that? So here, look at this thing. Here, tension is T. Here, tension is 8T. Meaning, here, if I put 10 kg ka block, here I can lift 80 kg ka weight. So with a 10 kg ka weight, I can lift 80 kg ka weight at point A. So you get 8 times more force for every, whatever is the B ka value, you'll get 8 times the weight at point A. So you can increase the force that way. It's called a force multiplier. You can lift heavy objects with smaller weights. Anyway, so that is one. But any doubts on this page, please ask me. That's it. This is the main thing there. Now, method 2 have some problems. We will see them later on. Method 2 gives incomplete answers. If there are forces other than tensions are involved. If you see method 2, right, we only took tension forces due to the power due to tension. But what if there are other forces? If there are other forces responsible for power transfer, we have to include them also. So then this method will not give you a complete answer. It will give some partial answers. We will see those cases. Second thing, method 2 is only valid for velocities. And it can be used for acceleration. Only if angle between tension and velocity is constant. I'll show you these things with problems, both the cases. That will be a better way to understand. Statements you will understand, but it really doesn't make much sense. First, we will do cases where it works properly, and then I'll show you slowly introduce the cases where it will start failing. And I'll show you how to recognize when it fails. Anyway, these are the two drawbacks that we have. So let's see a few questions on this, and then we will go ahead. What was the last thing that we did? Question 3. So I'll give you some cases. You find me the directions, velocities. Find VA. You getting how it is? So for A, the 3 strings are connected to A. Find the velocity of VA. Hmm. Right, Ovia. Right, Arya. Nee, Shaurya, that is wrong. Ishman, that is wrong. Get them easy. Like question is longer. The answer is actually pretty fast. Take a minute for both. I'll show you in a minute. Let's see. 3.5, 2 by 3, 2 by 3. Okay. Step 1, find the tensions. So start from anywhere. I'll start from B here. Let this be tension T. This whole thing is the same string, so this must be T. If that is T and T, this must be 2T. So this thing is the same string, so this must be 2T. If this is 2T, 2T, this must be 4T, then this must be 4T. So on block A, there are 3 tensions. So the total power on A must be 4T plus 2T plus T. That is the total tension on A into VA. Plus tension on B will be T into minus 2 because it is going down is 0. Are you clear with this? So when you say power on A, you take the total tension. If there are 20 strings connected, take all the tensions, due to all the 20 strings. That will give you 7T. So VA will be 2 by 7. Plus indicates the direction I assumed is right. I assumed up. So easy. Here also, same thing. Let this tension be T. If you look at this, it is the same string. So this is also T. It is the same string. This is also T and this is also T. So that means on block B, so you can just take this whole thing as one system. No need to find separately. There's a 3T tension. Let's assume A is going up. So power on A will be T into VA. Power on B, there are 3 strings pulling up, so 3T, and B is going down, so minus 1 is 0. VA is equal to 3 meter per second. I think that is right over here. I'll just check it out where it went wrong. Yeah, most of you got it. Easy? Not like method 1, length, x, y, differentiate. You can just ignore all that stories and just finish it off. Any doubts on fourth question? Please ask me. All clear with this? Let's see the next one. Let's get this one. So we have a boy here who's pulling the rope from both the sides with speed u, meaning he's pulling this side with u and he's pulling this side with u. He's pulling both the sides with u. Then the question is, what is the velocity of this big block here? Let's see. Any answers? We are right. Nishi Hari. See. So here, what is your system? Now be careful. What is your system here? The system is the man and the block, isn't it? These are the two people. So whatever power you're getting from the man must be equal to power taken by the block. So the points which you have to study is this point here, the point where the string is connected to the man. So this point is going with you. This point is going with you. And what are the strings doing to these points? The strings are pulling, isn't it? So this is pulling with T. Are you getting it? Getting it? So your hand is going, right? See, look at like this. If you're looking at my screen, my hand, when I'm pulling it, so this point is going with you, and my strings, right? This is the string which is pulling it back, isn't it? So string is pulling to the right because strings always pull, and the man is you going this way. Now be careful here. The tension is not same on both the sides. Look at this string. There is some catch here. This string is there. It is not the same string on both the sides. That means if this is tension and this is tension, this will be 2T. So this side, the tension is 2T. That is one of the trap you have to be careful. Both the sides, the tension is not same. Are you clear with this? Check this out. This is a different string completely. The man is pulling two different strings. Is that clear? That two strings are different on both the sides. Then you're done. Look at the tensions here. So this will be tension T. This will be tension T. This will be tension T. So look at all the tensions in the vertical direction. Tension T, tension T, and tension T. There are total 6 tensions, everyone here. There is 1, there is 2, there is 3, there is 4, there is 5, and there is 6. There are 6 tensions which are pulling it up. So you're done. So power of the man will be T and U are in the opposite direction. So T into minus U plus 2T into minus U. Power on the block, there are 6 strings which are pulling up, which is 60 into V. The total power must be 0. Minus 3TU plus 60V is equal to 0. V is equal to U by 2. Are you guys able to see the 6 strings? See, this is pulling up, 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 and this is pulling up. This will not be counted. This is ground that is not connected to the block. So there are 6 tensions which are pulling this lower block up. Is that clear, everyone? Any doubts on this? It looks complex and big. So the first thing is realizing the strings on both the sides are different. Clear, na, Srihari? Vanchika? Clear with this? Sudiksha? Shreyansh? Shaurya? Rudransh? Advay? Clear with this? Devanshi? Got this? Next one. So let's say we have a system like this. And let's say B is going up with 2 meters per second. Find VB. The B is sliding on the incline. Let's see. Anyone got it? 1 by 3, 4 by root 3, 2 by 3. Let's see. Now, let's be clear one thing. What is theta? Theta, when you write the formula, it is angle between tension and velocity. Okay, keep that in mind. When you write the power, which is T bar dot V bar, TV cos theta is this. Okay. Now, when you write the tensions here, look at this thing. Here, this is the tension T. This is tension T, same string. This is tension T, same string, and this is tension T. What is the angle between these two? 0, right? That 60 degrees is useless. It is a trap. That 60 degrees is nothing. I just gave it, so that you'll get confused. So power on A will be tension into 2. The angle between these two is 0 degrees. It is 2T. And power on B, I'll assume VB is going up. That will be 3T into VB. The total power will be 2T plus 3T VB is equal to 0. I'll get VB is equal to minus 2 by 3. So minus indicates it's not going up, it is coming down. Are you clear with this? So angle between them is 0 degrees. It's not 60 degrees.
So can you give the reason why we have to neglect gravity here?
What gravity you're talking about?
So I mean the G sin theta component.
Why didn't you ask me here then, MG? Suddenly याद आ गया यहाँ पे क्या हुआ था? यहाँ पे क्या हुआ था
Sir,
gravity?
I mean, I'm confused why we have to
What you're
neglect
confused?
gravity.
God, what are you writing here? What is this? Power due to
Tension.
tension. Gravity कहाँ पे है इसमें?
So we don't include gravity because the velocity is already inclusive of that.
नहीं, वो सब story नहीं है. You forgot the whole story only. What did we say? The whole thing. What is the total work done by tension? Work done by tension is 0. So power due to tension is 0. I don't care about other forces. You're getting it? What is the
Oh,
string trying to do here?
yes.
String is simply taking energy from one place and giving it to some place. Now, I don't care how that energy you got. Maybe gravity has given energy to block B. समझ में आ रहा है? Energy, the gravity is giving energy to block B. That I don't care. But whatever energy I'm getting here, it is sharing with that with A, na?
Yeah.
So the total
So,
energy given by the string is 0. Matlab whatever energy string takes from B, it gives it to A. We are just working on that part. We are not interested who gave energy to B.
okay.
A and B का बीच में जो भी transfer था, that must be, total must be 0. What, it's like, see, whatever, let's say you have 100 rupees, you gave me 100 rupees. So if you give 100, that is minus 100. If I got 100, that is plus 100. Total will be always 0, right?
Yeah.
You get the thing? Let's say you have 100 rupees, I have 0. Now you give the money to me. How much you lost?
100.
100. So minus 100. How much I gained?
100.
100. So it will be plus 100. Total will be
0.
0. Now, I don't care how you got this 100. I'm not interested in that 100. We are only studying whatever transfer that happens between you and me, that sum must be 0. Are you clear with that?
Yep. So when we talk about power and energy, we're just talking about for a specific force.
We are talking only about tension. This is all power due to tension is 0. That is a statement. We didn't say total power is 0.
Okay, sir. So, sir,
Got
power
it?
is for a specific force, no?
Power for specific forces. So we are only finding power due to tensions. If you come and say power due to gravity, gravity का खुद का power होगा. That will be mg into minus vb. We are not interested
Okay.
in that. We are only taking total power due to tension is 0. Why? Because strings will neither give you energy or take energy, they simply transfer. That thing is clear?
Yes, sir.
Shaurya.
Sir, like you made us write a point about drawbacks of this second method. We can't calculate. Like some cases, it would give us wrong answers when other.
No, suno. That's what I'm saying. Ignore for that. Now I'll tell you, explain more detail.
Oh.
If there are other forces for power transfer, so what is the other force that is between them? The force is between them. What is the other force between them, Bato? Both of them are connected by string, so that is one force. What is another force that is between them? Shaurya?
Sir, like no, sir, like I'm. एक second. Sir, I think normal होगा ना?
So मतलब ये normal A पे, ये normal इस पे आके इसमें act कर रहा है. That's what you're saying.
No, I'm saying कि like when we take components to mg sin 60
No.
वाला.
Listen. Don't talk about just because you remember something, you know something. What did I ask you? What are the forces between A and B? So there
The
is one string
tension.
connected here, so that is tension. What is the second force between them? वो बताओ.
So torque, like वो pulley पे torque.
Torque is not a force.
Okay, then no force.
तो वही हो गया ना? Then what is the problem?
Okay.
Then what is the problem? There you answered it yourself. Torque is not a force.
Thank you.
And there is nothing called torque here also. There is a force on a normal reaction. But my question is this N acting on this B also?
No.
So they are not related,
Okay, sir.
right? So this N is acting on the wedge, agreed, but is the wedge moving? So fine, there is no problem, then wedge is not moving. All clear with this? I'll show you those cases, don't worry about it. So let's see one more. So in this case, right, I just wanted to show you the 60 degrees is useless. Most people will use that 60 degrees. So be careful. Theta is not the angle of inclination, it is the angle between tension and velocity. Let's see one more. Always stick to the definition. The whole thing that we started the story is the total power due to tension is 0. So technically we'll not include other forces. I'll show you when other forces will come, but not like this. They both should be related to each other. There should be some other force touching each other. Like I'll show you one example. See, like this. Suppose if you have a block like this. Now see, when they both are moving, this normal reaction is pushing each other, isn't it? Now that is a force related to both of them. Then we have to include them. But in this case, they're not related. We'll see. So let's say this is A and this is B. This is 60 degrees and this is 30 degrees. And let's say VA is going with 2 meters per second. Find VB, assume both the blocks are in contact with the ground. Any other doubts on this? Please ask me, get things cleared. These are important. Hmm, 2√3, 2.8. Leave it in roots now. 0.866, 2√3. Let's see. Yeah, yeah, most people are getting 2√3. Maybe it is an answer. Let's check. Step 1, get the tensions. So here it is easy because the same string. So this tension will pull up. So remember, strings always pull. Let this be VB. So what I can do now, if you don't want to take all this cos theta and all that stuff, just resolve into components. T cos 30, T sin 30. This will be useful. So here also the components will be T cos 60, T sin 60. So the perpendicular components are useless because their perpendicular dot product is 0. So the total power must be 0. So this will be T. So power on A will be minus t cos 30 because it is pointing backward and velocity of VA is 2. Power on B, t cos 60 into VB. You're getting how I'm doing that? You can just resolve into components, take the component in the direction of velocity. That also works. Because the other component is perpendicular, the dot product is 0. The total power will be minus 2t cos 30, that will be minus t root 3 plus t VB by 2 is 0. VB is equal to 2 root 3. Easy? Any doubts on that? So this is another way to do. You can just resolve into components and finish it off.
Sir,
हाँ Aditi.
the last question जो आपने angle दिया था, that was just to dupe us, right?
Okay, that is just to confuse you. I
Okay.
wanted you to do
So
that
like
mistake.
the actual angle यहाँ पे we take.
This ना देखो ना टेंशन ऊपर था V ये था ये एंगल है ना.
हाँ, because it's the
In the
angle.
previous case if you see ना टेंशन भी ऊपर था V भी ऊपर था, both are parallel vectors.
अच्छा, yeah, alright.
Let's see the actual question.
Sir,
So we have a
the
rod
string
here.
is the constraint, right?
String, that is a column. It's called string constraint.
Okay.
Our subtopic का नाम ही string constraint है रे.
Sir, I mean,
String is the one who is restricting them.
So what I think about is that if we equate the velocities along the string,
Yeah.
then we'll get an easy answer because if one is greater than the string will break.
ये करके देखो मचो. Do this and tell me. Now what you're saying is true, but every time it won't be so easy to say that. So we got a ring here. So this ring is sliding on a horizontal rod. So V ring is 2 meters per second. Ring slides on a horizontal rod. And VB here is going with 3 meters per second. This angle is 60 degrees and this angle is 30 degrees. Find VA. You're getting how is this? So this string here is going through the ring here. So if I draw the picture here, see this is how it looks. So the ring passes through it is not tied to it, okay? The string is passing through the ring. So it can freely slide. Meaning, think of like this. If you're looking into my screen, right? This is the ring and this is the wire. So this wire can move like this. Are you getting? It is not attached to it. It is not attached like this. It can freely slide inside of the ring. Now, and someone, what they're doing, they're pulling this ring now. Is the picture clear, everyone? Find the velocity of A at this instant. The next moment angles will change. We'll not get into that. At this instant, what is the velocity of A? Anyone who didn't get the picture, please ask me.
So can you
Let's see.
explain that again?
Which part?
How is this like working, like the string through the ring, but like
So you're pulling B here. If you pull B here, B will come here after some time. In this process, ring will come here sometime. So A will get pulled forward.
Oh, so that's the
So B and C both are moving.
अच्छा.
In that process, they're pulling A also with them.
हाँ जी. All right.
So find VA. I think Ovia, I think that is right, but let's see. You got something else. You got 1 plus 2 root by root 3. Ovia got 2 plus 1 by root 3. Arya got 2 root 3 by 1 by root 3. 3 different answers. I don't know what is the answer. Let's see how will you guys do this. I'll give another 30-40 seconds. Try. A minute more. There are two ways you can do this. One, the regular one, and Aditi, that is definitely not the answer. 2 plus, I think Shaurya, you got the same answer as Ovia. So I think we have two answers, 2 plus 1 by root 3. I took 2 with LCM. Okay, maybe then that might be right. Yeah, I think most people are getting 2 plus 1 by root 3. So how to do? Same story. So this is your tension, T. So what will I do for convenience? I'll resolve them into components. T cos 60, T sin 60. So this is also tension here. If that is 60, this is also 60 degrees. T cos 60, T sin 60. There is another way to do. I'll show you that also. That becomes faster. But every time you won't be so lucky, like, it will be like this. Here, this tension is also T. T cos 30, T sin 30. Remember, this thing is also T. So basically, this ring which you have, because when the string is passing through this, you can assume as if there are two tensions pulling it, T and T. Are you getting how you can assume? It is two strings pulling you. This angle will be 30. So this will be T cos 30 and this will be T sin 30. Please have a look at the tension components. So we will take the tensions only in the direction of velocity. So power of A will be T cos 30 into VA. Power of B will be tension is backward, velocity is forward. I'm putting a minus sign. T cos 60 into VB, that is 3. Power of the ring. Now remember, there are three systems here. Total power has to be 0, the ring and the two blocks. Now on the ring, the tension in the forward direction is T cos 60 minus T cos 30 into 2. Is that making sense, everyone? This was 60 and this was 30. So this component was T cos 60 forward and this component was T cos 30 backward. I won't take the perpendicular component, it is useless. Any doubts on these three powers, please ask me. Then once you got this, you're done. Total power has to be 0 because strings will not give you energy, they'll not take you energy. So when you add all of them, T will go off. You will get VA cos 30 minus 3 cos 60. Cos 60 minus cos 30 into 2 is 0. You can simplify this. I think you'll get V plus 2 plus 1 by root 3. I will leave it. So I think most of you did get this. I'll write it down directly. You can simplify and check it out. You'll get the same answer. Is this clear, everyone? This is one way to do. There is a little faster way to do. But like I said, I want you to know this method. You know why? Tomorrow someone will say there are two rings like this. This method will still work no matter how many things are moving. Now the alternate method which I'm going to teach you is faster. What you can do, the ring is moving now, stop the ring. You can use relative velocity. Alternate, solve with respect to ring. That means you go and stand on the ring. This is the observer. So the ring will think, okay, I am at rest. And you know what will be the relative velocity? Now VB ka velocity will become VB with respect to the ring. B is going forward with 3 and the ring is going with 2. So that will be 3 minus 2, 1 meter per second. So ring will think B is going with 1 meter per second. And this velocity will be VA minus 2. 30 degrees and 60 degrees. Now, doesn't this look like the first part of the problem? This is tension. This is tension. So this will be T into VA minus 2 cos 30. This will be minus T cos 60 into 1. TT goes off, you will get VA minus 2 is equal to, that's 1 by root 3. VA is equal to 2 plus 1 by root 3. If I use relative motion, you'll get a little faster. Clear with this? It looks good, but then again, the previous method also do remember that. Yeah. But like I said, right, if there are two rings like this, now you'll have a problem. Then it becomes more complex using relative velocity. Anyway, nothing wrong. Both the methods are right. Clear with this? Any doubts on this?
Yes, sir. In first method, is like the ring is moving because of the two tension forces, or is it?
That we don't know. That we don't know, Aditi. See, one thing, see, when I say 2 and 5, 3, there might be other forces who are pulling it. We are not asking who is that.
Okay.
Somehow it got 2 meter per second, maybe due to the tension, or maybe not. Think about it. Why will B go on its own?
Yeah.
Someone
That's
must be tracking it, na? So there are other forces whom we are not seeing. We are not interested.
Manji. Yeah.
So somehow B got 3, C got 2. Then what is A? So that's it.
अच्छा, and we're taking tension वहाँ पे क्योंकि the string is going through the ring and then.
Through that. So there'll be 2 strings pulling up.
Okay. All
It's
right.
like if I put a rope on your neck and if I pull it, there are 2 ropes pulling you, isn't it?
What the hell? Sir.
It is more easy to visualize that way. Oh, yeah, bolo na.
When we're applying relative, how do we know that the ring is not accelerating when that force is zero? But if it is not, then B and A.
No, we are only finding relation between velocities, right? Where are the forces ka baat hi nahi hai. We don't care about accelerations. We are not finding any accelerations. If you want to find acceleration, then you might have a problem. This is just a relation between strings, right? If this is 2 and that is 3, A has to go with this much only. Or else the string will either break or it will, stretch or it will get compressed. So your doubt is what if ring is accelerating? Maybe ring is accelerating. If you ask me, obviously ring must be accelerating because the horizontal forces tensions are not equal, na? There is a net force on the ring. So constraints doesn't care about what are the axes. This only gives you a relation between velocities at this instant. See, that is the word. At this instant. Next moment, ring ka speed will change, B ka speed will change. Then A ka speed also will adjust accordingly. Clear with that? It's a pretty good one. Have a look at this if you ask me confused. I know there are too many forces I drawed here. That was a little concern. That's why I drawed it separately here, see. So I'll just try to make this a little bigger. Take a small break. Come back by 9:36. We'll continue from here. Now we will slowly go into little higher levels. Any doubt so far? Come back in 5 minutes. There, we have two blocks here, A and B. So velocity of A is U. Velocity of B, we don't know. So the thing is, someone is pulling A, that's why it is moving. It won't go on its own. So this is a point P on the string, and this is a Q is a point on the string. So P and Q are points on the string. Find velocity of B, velocity of point P, and velocity of point Q. Let's get this. So we have two blocks A and B connected by pulleys as shown. So when you're pulling A, B also starts moving with it. So if A is going with you, find the velocity of B, and with a marker, you mark the 2 points on the string P and Q. So with what velocity those P and Q are also moving. Let's get this. Get me P and Q ka velocity. I'm more keen on that. Yeah, B is right. Most of you got it. Hmm. Do you? Okay. मेरे समझ it won't be 2U. It can't go faster than the block, है ना? Nere Aditi, how did you get that? See the first part, B is easy. So how many tensions are there? So this is pulling here, tension T. This is pulling here, tension T. This is pulling here, tension T. So there are 3 tensions on A. The same string is here. String is pulling, string is pulling, string pulls, and string pulls. There are 4 tensions here. So this will be 4 times tension VB. That will be minus 3 times tension because the tensions are left side and the velocity of A is U is 0. So VB will be 3VA by 4. There, that's an easy one, straightforward. Clear with this? How do you find for P and Q?
Sir,
हाँ Aditi.
the tension B block पे जो लगेगा, like in the last string, एकदम जो last में, which is attached to
ये ना,
the
that only 2T ना, वही तो है. These two tensions only will act here.
जो एकदम नीचे वाला है, which is attached to the
Yeah.
fixed part of the, हाँ.
Uh,
Why wouldn't it be T by 2? I mean, if you
अरे ये सब सेम स्ट्रिंग है रे, देखो ना स्ट्रिंग कहाँ पे चेंज हुआ?
वो तो टेंशन तो सेम रहा है.
पूरा स्ट्रिंग तो सेम ही है.
Yeah.
नेरो हो गया, that's not the answer. नहीं शौर्य, that's not the answer. नहीं आ रहा. Anyone else? How to get P and Q? So listen, I'll show you one for P. You do it for Q. Nere area. U by 4. Let's see. Understand one thing. You can't have a point going faster than A. If you're getting answers greater than U, that means there's something wrong. So how to find for this guy? So listen, this is the idea here. Since you want to find velocity at P, cut off the string at point P. And assume there's a small block here called P. Tell me one thing. Again, what is the story? The total power developed by a string is 0. That means even if you take a part of the string, shouldn't the power should be still 0, isn't it? Even if you take a full string or a part of a string, the power will still be 0. So imagine the string is cut at P and assume there's a block there. Now you can, if you want, you can even take the lower part of the string also. Imagine the string is cut at P and connect a block. Now the question has become between 3 blocks here. So what are the tensions? Tension, 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 and tension. Again, understand constraints, right? We are not bothered about the blocks. The whole constraint is based on strings. The total power developed by this string must be 0. I don't care about the blocks. So that string, whatever power you're taking from A and whatever power you're taking from B, you must be giving that power to P. Isn't that the meaning of it? The total power developed by a part of a string or a full string, it doesn't matter how much you take, it is always 0. So I'll assume P is going forward. You can assume any direction. So what is power on A? So power on A plus power on B plus power on point P must be 0. For A, T and V are opposite. T into minus U, there's only one string here. So we are only taking a part of the string. B pe there are two tensions now. 2T into VB. VB we just now calculated 3U by 4. This will be minus T into VP. T goes off. This will be minus U plus 3U by 2 is equal to VP. So VP is equal to U by 2. You got plus sign, means my direction is right. Are you clear how to handle these things? Is that statement making sense? Even if I take only a part of the string, since the string cannot take power or give power, even a part of the string power must be 0. So if you cut it at point P and assume if there is a block, the string will still give us 0 power. Anyone, how we are going to know?
Sir, how will we like consider like which part of the string we have to consider? Like in
You take the lower part, same answer aayega. Even if you take the lower part of the string, you're saying you'll take this part, na? Same answer aayega. If you want, I'll show you. See, if you like this, right? You have a block assume karenge. So इसमें 2T होगा, इसमें 2T होगा. This will be T and this will be VP. Try and you'll get the same answer. It doesn't matter which part of the string. Once you cut it, they'll become two parts. You can choose any part. Now, can you guys do it for Q? There I showed you for P, you do it for Q. Like what you obviously said was right. When you cut it, there'll be two parts. Which part to take? Doesn't matter. You choose whatever you want. Aditi, you got it. Vanshika, can you tell me right or left? Because minus sign I won't understand. So, near ho gaya. Right, Samya. Give me right or left also. Same thing. If you're cutting at Q, you can get up or down. I will take the lower part this time. So interestingly, if you take the lower part, A is disconnected from the circuit. Isn't it? You could have taken the upper part also. So A is not there in the picture only. A is useless. Tension, tension, tension. So power on B will be 2T VB. I'll assume Q is going to the right. This will be minus T, VQ is 0. If you want, you can take the upper part. Check, you'll get the same answer. So VQ will be 2 VB. So I'm getting a positive sign, means it is a right direction, 3U by 2. There. Right one. Vanshika, check your sign. The strings always pull. So got the calculations, everyone? No, we are not convinced. You want to take the upper part?
Sir, like, can't we take like a P, A, and Q as a
ले सकते हो. P and
like
A and Q. ठीक है, ले लेते हैं भाई. You wanted, I'll show you one. ये P था. ये Q था. This is what you want to take? ठीक है. Strings will pull T. String will pull T. The string will pull 2T. यही लिया tensions. This is U. P का velocity कितना था?
3U/4.
U by 2. VQ is this. So P का power क्या होगा? T into U by 2. Q का power क्या होगा? T into VQ. This will be minus 2T into U. Got your mistake? There. You can take PQA also. Nothing. That's what I'm saying. It doesn't matter. You choose any part of the string. The power has to be 0. You will get the answer. So it's a pretty good technique here. Generally, they'll ask you for blocks, so it is easy. Most people can do. But if you ask you somewhere in the middle of the strings, this is how you handle it. Just cut it there. Put a block. You take any one part and you solve. You get the answers. Is this clear, everyone? Any doubts? Anyone not convinced with this? Anything that you're not clear with this, please ask. Clear? Like I said in the beginning of the chapter, there are two main parts, constraints and FBDs. FBDs are easy. Constraints you're comfortable. The NLM chapter will be a breeze. You will just go through it. There's not much. So we will try to do it as detailed as possible, as much as we can. So don't worry about that. So understand, you're confused, ask me. You're hesitating, stay back after the class and ask, but get them cleared. Let's see one more. Let's go a little higher. So if it's an advanced question, this is how they'll frame it. So we got a ring here. We got a pulley here. This is A. This is the ring. This is going with a constant speed U. So someone is pulling the ring with a constant speed U. This angle is theta. This height is h. Ring slides horizontally with speed U. Find the velocity and acceleration of point A. This is a very important question. Let's. Velocity is easy. I'm more interested in acceleration. That is a trap. Think, take 2 minutes. Get the velocity part first, that is manageable. From the power method, you'll get it. Let's see how you do for acceleration. I'll give you one more like this, so you'll get used to this part. Velocity is easy. This will be mostly like a more than one choice question. This h here is anyway constant, so height will not change. Let's see. Near आते थे. Speed u sin cube theta by near आ रही है. You got something close. देखना पड़ेगा. Sin cube theta by h. Let's see. Listen. The first part is the velocity. So let's say this is going down with VA. What are the tensions? Tension is up. Tension is this way. So using the power method, we'll get power on minus T into VA, that is power on A, plus T into cos theta into U is 0. So we get VA is equal to U cos theta. This is the easy part. Now, the most common mistake what people do is this. They write VA is equal to U cos theta. Since you want acceleration, differentiate with respect to time. And this will become dVA by dt. This will become cos theta du by dt. But you said U is constant. Therefore, we will get VA by VA's acceleration of A is equal to 0. Be careful, this is wrong. Okay, that is wrong. Why? Because when you got VA is U cos theta, you're forgetting here. Theta is also changing, isn't it? Theta is not constant. When the ring comes here, didn't theta change? So you have to use the product rule. So at this instant, it is theta. Every instant, theta is changing. That's what makes this problem a little different. Theta is variable. So when you differentiate this, dVA by dt, this will be cos theta du by dt. Agreed, this term is 0, plus u d sin theta cos theta by dt. This term will be 0. This will be acceleration of A is equal to u. Cos ka differential is minus sin theta. Chain rule d theta by dt. Till here it is great. Now we are stuck with the d theta by dt. U sin cube theta by h. That looks right. You guys might be right. Right. So then d theta by dt. Now, how to get d theta by dt? Now again, go back to this. So we have a ring here. This distance is h. Let this distance be x. And this angle is theta. So from here we get tan theta is equal to h by x. Differentiate on both sides. So if you differentiate on both sides, tan ka differential is sec square theta d theta by dt. H is constant, so 1 by x ka differential is minus 1 by x square dx by dt. Now be careful, what is dx by dt? X is decreasing here. Dx by dt is minus vb, or vb is minus dx by dt. Negative, since x is decreasing. So we'll get from here d theta by dt is equal to minus h by x square secant square theta, and dx by dt is minus vb. There, we got d theta by dt from here. This is vb h by x square sec square theta. So take this and substitute here. This will be minus u sin theta. Vb ka value is how much? Vb is u, that is given. H is h only. What is x? X is h by tan theta. H h square by tan square theta, and this is secant square theta. Phew, that would be sine square by cos square theta. Cos square theta, secant square theta will cancel. Sine will go up. You end up with minus u square sine cube theta by h. That is your acceleration of A.
Well, can I suggest a better method there?
Lolo?
Sir, if we look at the like the initial length of the string, like
Hmm.
the hypotenuse of the triangle, so we'll find
You are
that
trying to
the
use omega, na, angular velocity.
yes. So we
अभी
can use
circular motion
theta.
नहीं हुआ ना, अभी circular motion नहीं हुआ है. Let's not introduce it. That's why I didn't bring it. What you're
I
saying
mean,
is
sir,
right.
you
हाँ,
showed
it
it
will be
like once
faster.
in the.
वो है, but let's not bring it. अभी circular motion आ जाएगा. I have to tell you what is angular velocity and all. Let's keep it this way. We'll see later on when it comes in circular motion. Yeah, that is a good method. I would suggest that. I would have done that, but circular motion is not over. And I don't want to introduce so many new things, but there, it's pure math. Have a look at this. So the thing is, the biggest headache was d theta by dt. So that was the reason the h was given. Basically, from that triangle, you can get d theta by dt. Clear with this? I know it looks complex, so definitely make sure to try this again on your own once more. Let's see one more like this. Any doubts on this? It's pure max, huh? Matlab, physics got over once you did this. This is the reason, this is the reason for that first statement there. Second statement, I guess. There. So method 2 is valid for velocities, but right, and can be used for acceleration only if the angle between velocity and tension is same. So if in our problem, if you see the angle between tension and velocity is continuously changing, right? That's why I cannot say A is equal to, AB cos theta directly. Are you clear with this? So if the angle is changing, you cannot use the power method for accelerations. You have to go through all this differentiation and headache. Let's see one more like this. Now you got an idea, so you should be able to try. We have block A here. Let's call this block B. Let's call this also as block B. So there are two block Bs. So B is going down with U constant. This is also going down with U constant. So this A will go up. Let this be angle theta, let this be angle theta, and let this distance be D between these two. Find acceleration of block A at this instant. Let's get this. I want acceleration, right, Shaunak? And velocity is not 2u cos theta. Velocity is u cos theta only. Actually, u by cos theta. Try. I'll give you 2-3 minutes. This thing again has a lot of math and differentiation. Try. I'll give you 3 minutes. Give it a try. The answer is bad. It is not good. Let's see. First, let's get the velocity part. That everyone must have got it. So let this be tension T. Let this be tension T. This is tension and this is tension. There are total 3 blocks. So total power has to be 0. So T into minus U for the first block. 2T cos theta into VA for the A block, and then again minus T into U for the next block. So you end up with minus 2U plus 2VA cos theta. Therefore, VA is equal to U by cos theta. U sec theta. I hope this everyone got. 2U square tan cube theta by D, right Samyak? 2U sin cube theta नेरे आ रही है. Right हो गया. U square एक 2 missing error हो गया. Check करो 1 2 is missing. Tan square tan sin theta भी आया क्या? नेरे उत्साह. You got an extra sin theta there. So if you want acceleration of A, we need to differentiate this. So dVA by dt. That would be U. Sec theta का differential will be sec theta by dt plus sec theta du by dt. So we get acceleration of A will be U. Secant theta का differential is secant theta tan theta. Hope you remember that d theta by dt. That's your secant theta ka differential. So if somehow I can find that d theta by dt, my job's done. So let's find that. So again, you're making this triangle here. This distance is theta. Let this distance be some y. And this is d by 2. So from here we'll get sine theta is opposite tan theta is opposite side d by 2 by adjacent side is y. Differentiate on both sides. Tan ka differential sec square theta d theta by dt. D by 2 y ka differential is minus 1 by y square dy by dt. Be careful here, a is going up. That means when it goes up, y is decreasing. Minus dy by dt. So you have to be careful with the signs there. If y is decreasing, it is minus. If it is going down, y would increase, it as plus. So we get d theta by dt is equal to minus d by 2 sec square theta. And what is y? Numbers are bad. D by 2 tan theta. This will be d square by 4 tan square theta. And dy by dt is minus va. That is minus u sec theta. Phew. So I hope I'm right so far. Then simplify this. 1d will be left, 1 2 will go up, 1 sec theta will cancel. Get a tan square theta, that will be u by 2d tan square theta by sec theta. Take this guy and substitute here. I think I'm getting a 2 now. So take this and substitute here, you end up with a u sec theta tan theta u by 2d. There's a 2 on the top actually. 2u by d tan square theta by sec theta. Perfect. That sec theta got cancelled. You are stuck with 2u square by d tan cube theta. That's your acceleration, everyone. Check this differentiation. This is the headache part. Minus because see na, if a is going up, what happens to this length? Is y increasing or decreasing? It's from differentiation, right? No, normally na, when it is going up and down, we take positive and negative, right? That's for regular problem. But when you're using differentiation, you have to ask yourself, if it is going up, the y is decreasing continuously, isn't it? So dy is negative. The same way in the previous problem, see here, why did I take vb is minus dx by dt? Because when it goes to the right side, x is decreasing. Clear with that? Any doubts on this differentiation? So the component of A along perpendicular to the string, right? Yeah, you should take VA ka thing perpendicular to the string. But I'm not sure. Once try and see if you're getting it, then great. All clear with this? Let's see one more like this. Not like this, something more easier. So let's say we have two parallel rods. So you have a string like this. So at this point, the string is there. You have a ring here. This is ring A. This is a ring B. So we got a string of this sort. This angle is theta. So someone is pulling this ring A with speed u. In this process, the ring B will start going up. So we have two parallel rods. The string is fixed at point O. And then it passes through ring A. It is not attached to A. And then tied to B. So this point here, it is tied. Are you guys able to visualize the picture how it is? Now see what will happen. If I pull this, ring A is coming down. So in this process, so the picture would look like this. So initially ring A was here, ring B is here. So when you pull this ring A down, this is what happens. A will come down, but in this process, B will start going up. Are you able to visualize the picture how it is? So there are two parallel rods, right? And the ring is one. So when you're pulling this ring down, what are you doing? When you pull this ring A down, won't the string become like this? Are you guys able to visualize the picture how they both are moving? Any doubts on that? Please ask me. Anyone didn't understand the diagram? So both the rings can slide on the two parallel rods. So it is like this. So initially, let's say ring A is here and ring B is here. The string is going through A, it is not, and it is attached to B. Now, when you pull ring A down, A will come here. In this process, B will go up. The string becomes like this. So A is coming down. In this process, B is going up. Is this picture clear, everyone? So can you find the speed of B then? If A ka speed is constant, if A is pulled down with speed u, find VB. There, let's get this. VA sec theta minus 1 right हो गया. Right Samyak. Right Arya. Let's see. Same story, you just need to draw the tensions and finish it off. So just look at the tensions. If you look at ring A, how many tensions are there? The string is pulling up and the string is like this, isn't it? If the string is going through this, you can assume as if there are two strings there. So whenever it passes through, you can just relate it to be two strings. And this guy is going down. This angle is theta. So power on A, if you look at the components, so this will be t cos theta and this will be t sin theta. So power on A will be t cos theta minus t into VA. If you look at power on B, this was easy. If that is theta, this will be theta. This will be tension. So power on B will be TVB cos theta. The total power has to be 0. TVA cos theta minus 1 plus TVB cos theta is equal to 0. So VB will be U 1 minus cos theta by cos theta. Yeah, you can divide them. It will be sec theta minus 1. Clear with this?
Sir, if we want to use the method of taking components of velocity along the string, then we will have to take two components of u, right? Like one will be
It'll be too
u.
complex. रे, भाई बोल रहा हूँ ना. You will get it sometimes. Sometimes you'll get confused. Stick to one method. Yeah, what you're saying, we have to do that only.
So I took like one component u and one minus u cos theta because it is reducing, and same with
Yeah.
v.
You can do that. But that's what I'm saying. In the exam, you'll be like so thorough with it. Just one minus sign, you mess up, the whole thing will go for a toss. So stick to something which is more reliable, nothing much. There, you saw some problems. So this is how we have a method too. So we have strings and all, you get it great. But now there are certain models, where this does not give a proper answer. Right? So it's a combination of method 1 and 2 kind of. So listen to the technique that I'm going to teach you. So remember in method 1, what we did, the length of the string was constant. So the same thing, but I'm going to show that in a little different way. Listen to this example. Let's say we have a block A. And let's say we got a pulley. We got a string here, which is fixed. This is kind of more intuitive, actually. You see and you observe stuff here. Now, look at this thing. You have two blocks, A and B. Now, let's say if A is going by X forward. If A goes by X forward, then even this pulley also will go X forward. Then what will happen to your picture here? This fixed point will remain same. So this whole picture will remain same, except your A, which is here. Now that will be little forward. Isn't this what will happen to the picture? So from here to here, this distance will be X. Agreed? If A is gone forward, so from the center of the pulley to this center, shouldn't this distance also be X? Agreed? Now, this is my question. So if that is X, what is happening to all this string here? So if you look at this shaded part here, this also will be X and this also will be X. What will happen to all the shaded part of the string? All the shaded part of the string becomes loose, isn't it? This shaded part of the string becomes loose. If A actually goes forward, it has to become loose. But tell me one thing, can the strings ever become loose? So the strings cannot become loose. That means whatever that you lost, someone should take it. That means the only person who can take it must be B. That means B must have gone down by 2x. Is that logic making sense, everyone? You're getting, there's no technique, nothing there. It is simple visualization. If the A goes forward, there are two strings which are getting loose here. All that loose string should go somewhere, and the only person who can take it is B, so it will go down to X. Is that making sense? Simple visualization, that's it. We are just observing it. So when block A moves forward, the pulley connected also goes forward by X. And we observe the shaded part becomes loose. This loose string is absorbed by B. Therefore, B moves to X. That simple logic there. If A goes by X, B goes by 2X. You could have done this with your regular method 2 also. Is the idea clear, everyone? No. Let's say if I combine something of this sort. We have two blocks here, A and B. Are you getting how is the picture? The string here is connected at the bottom. So this string is going like this. It goes over two pulleys. Then it comes back and it comes in attached to the block. So this block A is sliding on this big block. Let's say if B block is going with speed U, find the acceleration of A. Find velocity of B. Find velocity of A. Let's see how will we do this. So,
Sir,
hmm.
sir, like you explained us one concept before this question. Like, sir, what was the need of it? Like, because in method 2 also we'll get the same thing only. So, like, why would we define a new concept?
What is a new concept? This one?
No, like, why would we define this like before this? Yeah.
Okay, so do this thing with method 2 and give me the answer.
Method 2 or this method which you taught?
You don't want to use that, right? Without using that, you're saying you can get an answer. Is that what you're saying?
No, like I'm asking, like you only told no by using method 2 also we'll get the same thing. So like why would we need one more like this type of?
That is for this question.
Yes, sir.
So for this question, you will need it.
Okay.
So I'm just telling you, you can do the same problem in multiple ways.
Okay, sir.
So for this method, you will need it. So I have to teach you something, right? I have to teach you something from where you know.
Okay, sir.
What is the answer for this thing? You give me an I cap, J cap, no, God. That's anyway wrong, Arya. Is the diagram clear, everyone? So when the B goes forward, the block A will start moving. So what is the velocity of that? Nere Arya, that is wrong. Nere Samyak. So here, if I use only method 2, you'll only get a part of an answer. So here, there is a normal reaction between them. So the energy transfer is not only happening due to string, but it is also happening due to the normal reaction. So if you use method 2, you get an incomplete answer. You get only velocities in the direction of string. Yeah, that's the thing. Anyone else got it? Samyak got it. Nay, Srihari. Arya, get your signs right. You got the numbers right, you messed up the signs. Anyone else? See the picture. Just know the method which I taught you. What are you supposed to do? Just push the block little forward and see what happens. So if I push this little forward, now see. So from here to here, let's say if this thing goes forward by u. So from here to here, look at this pulley here. Can someone tell me what happened to this string here, the shaded part? And what happened to this string here, the shaded part? How much will that be?
X.
So if I take 1 second, if it has travel speed u, then this will be u. This will also be u. Let me take it as x only for you. So this is x. This is also x. This is x. Do you agree? So now you tell me, where will all the string go? If that is x and that is x, all this loose string will go to point A only, right? There is no one else to take this. So this block will go down by 2x. But at the same time, observe this. A, which is here, A has also gone forward, isn't it? A also moved forward by x. Because the normal reaction is pushing it, it also went A forward. So if you look at the motion of A is doing two things. Because the string is getting loose, it is going down by 2x. This is your loose string. And it is also going x forward because the B is pushing it. Because they're touching each other. That means this A is actually going at an angle. So if you look at velocity of A, that will be u I cap because of that x and minus 2u j cap. So as this B is going forward, you'll actually observe A will go at an angle like this. Is that clear, everyone? Meaning you can see the picture, see. If you try to do multiple pictures here, you can clearly observe that. So this is A. Next moment, A will come down a little. Next moment, it will go down a bit. So let me draw it here only. So if A has come here, A will come here. Can you see how the motion of A is? A is going like this. So it's traveling forward by x and it is going down by 2u. Is this thing clear, everyone? It's again more of an intuition. You can just see and observe that. So whenever this thing goes here, you have two shaded strings. So when B moves forward, two strings become loose. And also B pushes A forward by x. It does two things. Is this clear, everyone? Sure. This is not a big trick or anything. You can see things and visualize. So it's kind of like a combination of 1 and 2 method. So everything you can just visualize and get it. Any doubts on this? We will do more of like this varieties in the next class. We'll see more variations of this. So next class, when we catch up, we'll continue from here. We'll see more variations of this and then also do something called rigid body constraint. So mostly we will wrap up constraints in the next class. And then after that, we'll go ahead with FVDs. I'll send you a small sheet on these things so you can try, right? Okay, with that, we'll wrap up for the day. So do make sure to go through all these problems again. There are 12 of them, and I'll send you a sheet right now after the class, maybe another 10-15 questions on string constraints. So you can do them. That should give you a good practice.
Thank you.
Okay, that will wrap up for the day. So any doubts, anything, please stay back and ask, or else you're free to leave. I'll see you guys again.